Good morning, good afternoon, good evening. We are back and better than ever. Of course, I forgot to say, whatever the case may be, we are going to go ahead and finish up Descriptive Statistics Part 2. Okay, so last time we had our 5-number summary of the data set, and that becomes important because we have to be able to construct what is called a box plot with a 5-number summary. Um, and what that allows us to do, a box plot, is it allows us to be able to get a visual picture of a set of data. So here we go. Consider this data set. Construct a 5-number summary for this data. So you would just have to put, if you had to do it by hand, which you probably won't, you will almost always be able to use a calculator, but it's possible. So you would just have to put the data in order, find the median, find the first quartile, and find the third quartile. And that is all you need to do in order to make a box plot. It's very, very simple. Okay, so I'm going to say temporarily that you start off with the lowest or the minimum value 2 as you put a dot there, corresponds there, and then the maximum value is 9 and you put a point there. I shouldn't have said dot, a point. Then your box is going to be created from the first quartile, the median, which is the second quartile, and the third quartile. And we're just going to put, we're going to make a box around or formed by actually the first and the third quartiles. And we just put a box there, a little rectangle in like this. And then we put in the a line where the median is. And then from there we draw lines from the minimum straight to the box, and then from the maximum straight back to the box. These are called whiskers. Okay, maybe you've heard of this as a box and whisker plot. Maybe you've never heard of it. That's fine. But for our purposes, we're going to refer to it as a box plot. Okay. Find the range of the data. Range max minus min. 9 minus 2 is 7. Interquartile range, that's easy. 6 minus 2.5 is 3.5. Okay, and then use the ordered data set in A, 4 of 16. Oh, whoa, find the percentage of data values that are less than 3. So that would be 1, 2, 3, 4 out of 16, which is 25%. It's kind of a silly question, I guess. You couldn't use a box plot to figure that out. There's no way to know. We can't see the data points, so we'd have to use the actual data set to answer question D. Now, I said I'm going to say for now that we put a dot at the left, or a point at the minimum and a point at the maximum. That's if we don't have any outliers. Outliers are data, they're extraordinary and are separated from the main body of the data. How do we know if we have an outlier? Well, we use this is a common way to identify outliers. The upper boundary equals the upper quartile plus 1.5 times the interquartile range. And any data greater than the upper boundary is an outlier. And the lower boundary is equal to the lower quartile minus 1.5 times the interquartile range. Okay? And if we do have an outlier, they are marked with an asterisk, and there could be more than one at either end. So there might be more asterisks. And each whisker will then extend to the last value that is not an outlier. Well, what does that look like? Well, here, this is a different set of data than we did before. We're asked to make a box plot for this. So they found their min, first quartile, median, which is the second quartile, the third quartile, and then the max. Okay, and then they did an outlier test. Well, to do the outlier test, we need the interquartile range, which is 10 minus 6.5 or 3.5. And here's the test for an outliers. The upper boundary is equal to the upper quartile plus 1.5 times IQR. the upper quartile, or this is also known as the third quartile, Q3 is equal to 10 plus 1.5 times the interquartile range, 3.5. So our upper boundary is 15.25. Same formula for the lower boundary, the lower quartile, Q1, except we're going to subtract and we get 1.25. Okay, so are there any data points greater than 15.25? And there is one, it's 16. So we're going to put an asterisk at 16 right here. Is there any data less than 1.25? Well, yes, there's a 1. So we're going to put an asterisk right here. So then we put our point, our first point, at the next value up from the from this outlier, which is a 3, right above the 3. And then same thing, the next piece of data less than the outlier 16 is 14. So we put the point here at 14. And then, of course, the box is formed by the lower quartile, Q1. This is Q1. This is the median, or Q2. And this is the upper quartile, Q3. And that's a horrible Q, Q3. And that's how we make our box. So not too horrible. Okay. And finally, this is called a cumulative frequency graph. Okay. What we have is heights of seedlings. Somebody planted something and it grew to a particular height, and we have a cumulative frequency table recording the heights of these seedlings. So a botanist has measured the heights of 60 seedlings and has presented her findings on the cumulative frequency graph below. Okay. How many of the seedlings have heights of 5 centimeters or less? Now this is often going to be an estimate. So you're going to want to take your pencil when you have this, and let's see, we have blue here, so I'm going to use I'll use pink line. Okay, and if you can, you want to draw lines. So how many seedlings have heights of 5 centimeters or less? So here's the height, and here's 5. So what I'm going to do is, as best I can, I'm going to draw a line till I intersect the graph, and then I'm going to go over, and you can see that it's not quite at 10. So a good estimate would be how many seedlings have heights of 5 centimeters or less. It looks like it's about 9. So I'm going to say about 9 seedlings have heights of 5 centimeters or less. Okay. Okay. So next question, part B. What percentage of seedlings are taller than 8 centimeters? Ooh, we have to think a little bit. What percentage? Well, first we need to do that same thing. I'm going to make a line up from 8. Ooh, they have a nice little mark there for us already. Isn't that nice? And so if we go straight over here, that looks to me to be about 44. Okay, so we have to think about this now. What percentage of seedlings are taller than 8 centimeters? Well, there were only 60 seedlings, right? So if there are 44 that are 8 centimeters or less, that means 16 are greater than 8 centimeters, and 16 out of 60 times 100 to change it to a percent gives me, and we're going to say this is about, so I'm going to approximately equal to there. That is about equal to, oh, I did the calculations, just give me a second. I don't have it in front of me. It's about 28%, equals about 28.3%. Okay. Find the median height. All right. Well, the median is the middle number, yes? Oops, what did I just do there? I don't know what I did, 60. Okay, I'm trying to get rid of that thing. Okay. So, 60 seedlings, right? So the median is between 30 and 31. So it's at about 30. Remember, we're estimating. So I'm looking at 30. I don't think I need to draw a line here, but I'm looking at 30. It doesn't quite intersect there, but it's pretty close. If I go straight down, the median is about 7 centimeters because it corresponds with the 30, halfway for the number of seedlings. So I'm going to say about 7 centimeters. Okay. Find the interquartile range for the heights. Well, the interquartile range is Q3, the third quartile, minus Q1, the first quartile, which is approximately equal to, well, the third quartile is the median of the upper half of the data, and that is going to occur, it's going to be the 45th seedling. So I'm going to, if I go over to, I don't have to draw a line because 45 is right there, but maybe I might want to draw a line straight down, and it looks to me like maybe that is about, I don't know, 8.3, you know, 8.2, 8.3, I guess I'll go with 8.3. So that's about equal to 8.3 minus, and I'm going to do the same thing for Q1, except Q1 is going to be at 15. So 15 goes here, and so that median is going to go down there at about, I don't know, what do you think, 5.9 or so? So 8.3, oopsie, what happened? Minus 5.9, and that is equal to 2.4 centimeters. So we're saying that again, this is, we already have the about here. That's about equal to 2.4 centimeters. And then the last thing we'll do is find the 90th percentile for the data. Okay, so what they're asking us to find is the number that is the 90th percentile. Well, in order to find the 90th percentile, we have to find out what 90% of the total is. So we would have to take 90% times 60, or 0.9 times 60, which is equal to 50. Not 54. Yeah, I'm sorry, it is 54. What's the matter with me? 0.9 times 60 is 54. Okay, so I have to start with the 54th, the 54th seedling right there. And so I'm going to take my line, and I'm going to say, okay, it's about there. Oh, they have a nice little dot for me. Isn't that nice? And that goes straight down to 10. Okay, so that means the 90th percentile is 10 centimeters. And what does that mean? Well, that means that 90% of seedlings have heights of 10 centimeters or less. Heights of 10 centimeters. Sorry about the mess. The messy writing, I mean, or less. Okay. All right. That is it. And I am out.